So today we are talking about rational functions, okay? So what is a rational function? It is a graph, just call it a graph right now, a graph with x in the denominator. Okay, let's just start there, okay? The problem with x in the denominator is we have a risk of dividing by 0. We can't divide by 0, because if we divide by 0, we get an undefined value, okay? So it changes the domain, doesn't it? So if we take a look at, first of all, the graph they gave us, it's our parent function. This is our parent function right here. This is the basic y equals 1 over x. They call it hyperbola, okay? What we want to know, more importantly, is this. If x is equal to 0, you guys watching it? If x is equal to 0, you will divide by 0, okay? So x cannot equal 0. And we talked about the fact that as you start dividing by smaller and smaller and smaller pieces, that you end up going to infinity. And that's what asymptotes do. Asymptotes are lines of infinity, right? So as we get closer and closer to dividing by 0, we get closer and closer to infinity. Asymptotes are, in a sense, lines of infinity, okay? So we have a horizontal asymptote at y equals 0, and we have a vertical asymptote at x equals 0. So wherever we divide by 0, we're going to find a vertical asymptote, okay? So far, so good. Talked about this. Should seem obvious, okay? All right, let's check and move the page over. Now, let's go to number 1. So, we just want a basic sketch. It doesn't have to be perfect, but one thing I'm going to do on this before I do a whole lot is I want to know where the asymptotes are. So, what can x not equal?
2.
X cannot equal what? What can x not equal?
Point 1.
What can x not equal? Come on, think about it.
1.
Can't equal 0. Can't equal 0. Can't equal 0. Why can't x equal 0 here?
Because you don't want it to.
Well, because you'd divide by 0, wouldn't you? So you'd have an asymptote. Well, because try to calculate 0.25. Let's check it out, okay? Okay, if you're not convinced, I'm going to go 0.25 divided by 0, and guess what? It even says don't divide by 0, but calculator agrees with me. Don't
0.25
divide by 0.
0.
So it means we'd have to have an asymptote at 0, right? And another asymptote at 0. Now, I'm not going to graph it overly accurate. I just want to get the picture, okay, of this one, okay? So it would look something like this. And, of course, something like this, okay? All right? And it's not perfect. It doesn't have to be. I want to get the general shape of this one. That's all. Okay, number 2. So before we do anything with number 2, what can x not equal? X cannot equal 0. You guys agree? Because if you divide by 0, it's undefined. So I know for sure that I'm going to have an asymptote at 0, right? And the y is also got to be 0, because if we can't divide by 0, we can't get an answer of y to be 0, okay? Now, because this is a negative 2, watch. Cooper, watching? Put your phone away. Because it's a negative 2, it's really x times y equals negative 2. Because if we rewrite this as y equals negative 2 over x, another way to write that is x times y equals negative 2. So, what times what negative 2? How about a 2 times negative 1? How about a 1 times negative 2? How about a 4 times negative 1/2? How about a negative 1? How about a 1/2 times negative 4? But either way, my graph looks like this, doesn't it? But I can also graph a negative 2 times 1. Negative 2 times 1 makes a negative 2. I can also go negative 1 times a 2.
Holy crap, it does.
I can also go negative 4 times a 1/2. That makes a negative 2. And I can also go negative 1/2 times a positive 4. So what I find between the two graphs is because if it's positive, you're going to find your graph in quadrants 1 and quadrants 3. Right? Graphs in quadrants 1 and quadrants 3 if it's a positive value. If it's a negative value, you're going to find your graph in quadrants 2 and quadrants 4. So far, so good? Thumbs up?
Uh-huh.
So if it's equal to a negative value, you're going to have your graph in quadrants 2 and quadrants 4, okay? Am I going too fast or am I okay?
You're okay.
Okay, turn the page. Okay. So now, number 3. Before I do a whole lot, real quickly on number 3, tell me what x cannot equal. X cannot equal what?
3.
3, everybody agree? Because 3 minus 3, we're going to have a problem. Now, put in my asymptotes. Excuse me, put in my xy axis. I'm going to put them over here. Now, I'm going to take my parent function. Okay, watch. I want to take this graph right here, and I want to move it. Take this graph and move it. In fact, I want to move this graph back opposite way. I want to go to the right.
Can you move it down?
Yeah, I'm sorry, Katie. I want to go to the right 3 and up 5. Because Ben said it really well. We're going to go the opposite direction, aren't we, Ben?
You're right, Mr. Davis.
Because that would zero it out, right? So I'm going to have so the easiest way to move these is by moving the, I want to move the graph, but let's move the asymptotes. Does that make sense? Let's move the asymptotes from 0, 0. We're going to move our asymptotes to 3, 3, 5. So let's go to 3, 5.
Mr. Davis, ignore my question.
Yes, Ben.
No, I actually meant it. I meant ignore my question.
Okay, I will ignore your question. Okay, there you go. Okay, then the graph has been moved to here. This is a positive one, you guys agree? So it's going to be in this region and this region. It's a positive one, so it's going to be in this region, this region. And I'm just going to do real quickly the multiples of 1, 1 and 1. I'll go 2 and 1/2, a 1/2 and a 2, and so forth and so on. I'll do the same thing, a negative 1 and negative 1. I'll go negative 2 and a negative 1/2, negative 1/2 and a 2. My graph goes like this, okay? How am I doing? So far, so good?
You're right, Mr. Davis.
So now, real quick, domain. What's the domain of this graph?
That you-
Real numbers
It's all real numbers.
3.
Except what?
0.
No,
3. 3.
3. Cannot equal 3 because it makes 0,
I was
right?
looking. So-
Okay, so if x were 3, if x was 3, if x were 3 right here, you'd be divided by 0. So don't let x be 3. So what's my range?
All real numbers except for 5.
Yep, all real numbers except for y cannot equal 5. Nice job. Okay, it's not that hard, is it? Okay, now, let's look at 4. Now what makes 4 different is the negative. Yes, Ben?
How do I remember domain?
That's my domain, right?
What
Reach
about-
for your range.
Oh, thank
Reach
you.
for your range and don't mess with my domain, right?
Yeah.
I know. Okay, so, real quickly, what can x not equal? What can x not equal?
X can't equal 0.
0's right, because if 0's right there, we're divided by 0. X can't equal 0. And then, so I know that my asymptotes are going to be at 0, negative 4. So my asymptotes are going to be 0, negative 4. Okay. 0, negative 4. Okay. Oops. I'm wrong. I do not have whiteout with me. Shoot. Ignore that. That's not there, okay? It's not there. My bad. That's not there, okay? Now, from right here where the asymptotes intersect, what times what makes negative 3?
Negative 1.
Okay, negative 1 and 3, I agree. Negative 1 and 1, 2, 3.
Or the top of it?
We can do that too. Okay,
I'm just like the asymptote.
3 and negative 1, yeah. Oh, this one, that's a mistake. This is a mistake. In fact, let me make that darker so you don't even see it. That's, okay, how's that? Is that better?
It's more like that's the line.
I know, I did make a mistake. Okay.
babies,
Yeah,
we're all humans, we make mistakes.
I do. So my graph should look like this
I'll just turn white out.
and this. Okay, so what I did is I only needed 2 points because I knew the shape. 3, negative 1, 1, negative 3. And then I can draw it in. How about a negative 1, 3 or a negative 3, 1? Really only need 2 points because I know what the graph looks like, right? One more time, you ready? From the center of the asymptotes, 3 times negative 1 or negative 1 times 3. From the center of the asymptote, negative 3 times 1 or negative 1 times 3. I only really need 2 points, right? Because I know the shape of the graph. You guys agree with that? I don't have to have a ton of points. I know what it looks like, okay? How about domain?
Wait,
X shall not be equal to
I don't know,
0.
I'm only really confused.
X cannot equal 0 in range. And Y cannot equal negative 4, right? Ben, I'm listening. I'm listening.
On the points in the bottom right, how did you get them? 'Cause, like,
Yeah.
from the asymptote.
From the asymptote. Okay, so give me what times
3,
what?
negative 1, I get that
Okay,
one.
3, negative 1. Okay, how about positive 3
Oh, it's
times?
1, negative 3, I was doing negative 1, negative 3, that doesn't make sense.
Okay,
so-
yeah. Okay, almost done. Number 5. Okay, here comes 5 and 6, okay? All right, they want me somehow to make it look, they want this to look like this. Now the reason you want to do it, because then you'll know what the Y value is for the asymptotes. Okay, now how do we do this? How do I make it go from this form to this form, okay? Long division. Now I'm going to go through it slowly. We've done it a long time ago. Long division. So check it out. And now this is my last problem I'm going to do, and then you guys we're going to be done. Okay, so I'm going to take x minus 5. I'm going to divide it into x plus 2. I'm going to do long division. Let's see if we remember how to do long division. Okay, step by step. Okay.
There's literally no way I'm gonna remember how to do that. Just-
Yeah, I bet you could if I help you real quick, Ben. So real quick, Ben,
Not me
You gotta
remembering.
answer video.
you ready?
I don't know.
I'm ready.
Let's do this first.
Oh my god.
X goes into x how many times?
One.
1. Good, perfect. 1. You guys agree with that? 1. So then we got to multiply. What's
Oh my god.
1 times x is a 1x, and a 1 times 5 is a negative 5, right? You guys agree with that? So since I'm dividing, I have to subtract, right?
Right.
Be careful of the double negative here. Be careful of the double negative. So x minus x is nothing. It's gone, right? But then I'm going to go 2 minus a minus 5. 2 minus minus 5 is what? 7. So here's what my answer is. To rewrite it, we are going to have y equals 1 plus, now that's my remainder. Remember, that's my remainder. So it's 7 over what I divided by. What did I divide by? X minus 5. Now, where would the asymptote be for this?
Plus 5, plus 1.
Perfect. And we can graph that in. We'll do it over here. So we have room. So we can graph this one in pretty easily now. Okay, so I'm going to go to my asymptote. Let's see if I do it right. Ben's totally right. I'm going to go positive 5. 1, 2, 3, 4, 5. And up 1. So my asymptote goes there. Okay. Perfect. Okay. So Ben's right. Positive 5, because of the opposite, and 1. Now, what times what makes 7? What times what makes 7? Yeah, so how about a 1 from here? A 1 and a 7. 1, 2, 3, 4, 5, 6, 7. Or a 7 and a 1, right? I only need 2 points because I know what the shape looks like, okay? So 1 times 7 and 7 times 1. Are you okay with that? From the intersection of the asymptotes, right? So I know what it looks like. Okay, what else? What times what makes 7?
1 and 7.
Yeah, but how about over here? What would I do here? Negative times a negative. Negative 7 times negative 1. 1, 2, 3, 4, 5, 6, 7. And negative 1. And what else? Negative 1 and 1, 2, 3, 4, 5, 6, 7. Okay? Awesome. What's my domain? What's my domain? X equals all real numbers except for X cannot equal what?
5.
5. Totally right. In fact, we got an asymptote at 5, proving that, don't we? What's my range? Y equals all real numbers except for Y cannot equal what? 1. Because I have an asymptote at 1. Okay.
Oh, yeah.
And let me stop recording.